Today we're going to look at inscribed angles. Inscribed angle is an angle with its vertex on the circle with two sides that are chords. Those are segments going through the circle. So like an inscribed angle is this purple angle in this image having chord BA and chord BC. Notice how the vertex is on the edge of the circle. That is what is called an inscribed angle. The intercepted arc is this red portion here. It is an arc that lies on the interior of an angle and has endpoints on the circle. So those are that arc AC there. Over here we have an inscribed polygon in red here, and the circumscribed circle in blue, which is going around it. An inscribed polygon is a polygon with all vertices on the circle, and the circumscribed circle is the circle that contains the vertices of the inscribed polygon. The rules that we're going to use, first one, if an angle is on the edge of a circle, it is equal to half of its intercepted arc. So this angle here is equal to half of this arc measure. This is the same thing happening, it just looks different. This is formed by a chord and a tangent line. A tangent line is a line that brushes the edge of the circle. It touches the circle in one spot and it doesn't go through the interior of the circle. So for this angle here, it would be half of this arc that goes all the way around to that point from A around to B. Here are some special angle rules that involve inscribed polygons. Here we have an inscribed triangle or angle and an inscribed angle here. If two inscribed angles intercept the same arc, then they are congruent. So this angle and this angle are congruent because they're both intercepting arc AD. And since they would be half of that arc AD, each of them would be that half of that arc, so that makes them equal to each other. If an inscribed angle intercepts a diameter, then it is a right angle. Here you have a diameter, BC. See how this angle has its endpoints at B and C? That will make it a right angle. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So like A and C will add to 180 and D and B will add to 180. Here are some example problems. You can see here that HJ is a diameter. That makes this angle a 90-degree angle. We also have the angle with vertex at H is intercepting this arc from G to J, which is marked as 100. That means that this angle is half of that, making it 50 degrees. So GHJ is 50 degrees and HGJ is 90 degrees. Over here, we have this angle marked as 120. The arc that it intercepts would be the arc ACB, which is a major arc, more than half of the circle. That's why they needed 3 letters. And so that arc is double of the angle, 240 degrees. On number 3, this angle at Q is 31, and this intercepted angle is intercepting arc RS, and the angle here at T also intercepts that same arc. And what that does is it tells us that those angles themselves are congruent to each other. So the angle RTS is also 31 degrees. For number 4, we're going to use the rule that says that if you have an inscribed quadrilateral, the opposite angles are supplementary, which is right above there. That means that P and R would add to 180, which makes Y 80 degrees. And then Q and S would also add to 180. So 180 minus 88 is 92. So that one's 92. Here I have a more complicated example. when you are doing these, it's very important to be on the lookout for diameters. Here is a diameter, and that means that all the way across here is 180. So we're able to find this piece of arc if we wanted to. So like 180 minus 134 is 46 for that portion. Being that this is a diameter, that makes this a right angle. And if this is 59 and that angle intercepts this arc, then you would double the angle to get the arc, making it 118. If you know that this is 118 and this is all 180 over here, this would be left at 62. If you take that arc and divide by 2, you'll get this angle at L, being 31. We can get this angle down here. It's intercepting the arc that's 134, and 134 divided by 2 is 67. So there's lots of things that we can solve using this information. So arc ML is this 118 here. Angle JLK, J to L to K, 67. J to L to M, 31. And arc MJ, 62. So that's how we would use inscribed angles.